Hello, in this video we're going to look at how we can do an experiment to see how the resistance of this component here, a light dependent resistor, often called an LDR, how that changes with light intensity. So, a couple of things first. First thing, a light dependent resistor. If we want to draw a circuit diagram of a light dependent resistor, circuit diagram, first of all, it is a resistor, so we start with just the general resistor shape. But it's a light dependent, so we use arrows to show light, and quite often it's got a circle drawn around it there. Okay, so that's a light dependent resistor, or as it's known, otherwise known as an LDR. Okay, so we're going to look at how the resistance of this changes when we change the distance it is from a lamp. And I've got this coloured lamp here, but you're going to be using just a normal lamp. Okay, so first things first, we're going to just have a look and see what happens to the resistance. And if you remember, what we're going to use here is our multimeter. Okay, so I've got my multimeter there, and I'm going to set it to 200 to start with. Okay, it's showing a 1 because I haven't connected it up to anything as yet. And we're going to connect up the light dependent resistor and see what happens. So I've got my component holder here that's connected to it, and I'll put the light dependent resistor in the component holder. Now I'm going to do that because they are quite delicate. It's fairly easy to get these legs of it to detach. So please could you make sure that you're using one of the component holders so that decreases the likelihood of it being broken. Okay, so I've put that in. I'm making sure it's facing upwards. And can you see on the multimeter it still says 1? That means its resistance is more than 200 ohms. Turn it up. We've got a resistance. Oh, but it's gone again, so it must be more than 2000. Turn it up again, and it's showing its resistance is just over 2000. Okay, it's 2.04-ish kilo ohms. Okay, so remember, if we're on this setting here with a K next to it, the reading it gives is in kilo ohms. So what we're going to do is we're going to have a look and see what happens when we put it in the dark. Now you can get a good idea of what happens to the resistance just by putting your thumb over the top of it, and you can see what's happening to the resistance when it's in the dark there, and you can see what happens again when it gets a little bit more light. Okay, so you can see the relationship straight away, but we want to be able to do an experiment and get a graph of our results. Okay, so what I've got here set up is, as I said, we've got the lamp. You'll just be using a normal lamp, but I've just got a coloured lamp so it shows up a little bit better. And I've got a meter ruler. Okay, I'm going to be moving the LDR away from the lamp and see what happens to the resistance. Okay, so the first reading I'm going to quickly take is when we've got the LDR directly under the lamp. Okay, so this is a distance of 0 centimetres from the lamp. Okay, and if I put my LDR directly under the lamp, you might be able to see on the, I'll just put this over here so we can see it, on the multimeter, it is reading directly under is 0.12 or 0.13. Now that's quite low. That's going to be 0.12 kilo ohms is 120 ohms. So I can probably get it to more precision by turning the dial down again. So there you can see, oh, it's saying 124, and I might even be able to get it on this reading, which obviously it's changing slightly because of differences in the light in the room. But this is going to give it to me more precision to 1 decimal place. So that's what I've got to start with. At 0 centimetres, I've got a reading of 121.5 ohms. Okay, so next thing, I'm going to move the LDR to 5 centimetres. So if I just move it to 5 centimetres, you can see that I've already got a little bit of an increase in the resistance. I've got 180.6 ohms. Okay, so 180.6 ohms. I'm now going to move it to 10 centimetres. Okay, so if I put that on 10 centimetres, what that does is it's now reading on the multimeter 1. That means I need to change the setting again. And you can see that that's coming up as 620 Well, it's changing quite a lot. I'm just going to have to choose one of the values. 620 ohms. Okay, so at 10 centimetres, it's 620 ohms. Move to 15 centimetres. If I've got that at 15 centimetres, I'll just move up my camera. I've got it at 950 ohms. So 15 centimetres, 900, and it's changing again. So I'm just going to have to try and write down an average. And there we are. So then I'll move it to 20 centimetres. And you can see at 20 centimetres, we've got an increase again. And at 20 centimetres, I've got 1,318 ohms. Then I'm going to move it to 25 centimetres. Again, I've got an increase. And I'm going to record 17.03 ohms. 30 centimetres. I've got 1,866 ohms. 35 centimetres. It goes to 1. So when you get to 1, turn it up again. And you can see here I've got 2.17 kilo ohms. Okay, so remember that's in kilo ohms. So what that would be is 2,000, it's changed again now, but if it was 2.22, that's 2,210 ohms. Moving it to 40 centimetres. Again, I've got it as 2.44 kilo ohms there. And 45 centimetres, 2.41 kilo ohms. Okay, and 50 centimetres, I've got 2.60 kilo ohms. Now, you'll probably see that, well, it's not going up as much now, and it's not changing as much because we've got further and further away. Eventually, it won't change much whatsoever because it will just be the light that's in the room. Ideally, we'll be doing this in the lab with the blinds down, the lights off, so it's only the light from the lamp that's going to affect it. However, you probably can work out that you've got lights from other people's lamps that are doing the experiments and stuff that provide limitations to this. Okay, so you're going to have a go at doing this. You're going to plot a graph of your results. I'm just going to put up on screen my results here just in case they're needed if for any reason your results don't work. Okay, so there's a set of results there just in case.